So Boolean expression is a logical statement that is either true or false. Means any expression that will give you results in two forms only, either true or either false. So that expression is considered as Boolean expression. So it can compare data of any type as long as both parts of the expression have the same basic data type. So like Boolean, if we have the same basic data type, then that Boolean expression will compare the data of any type. The thing is that both data should be same. So Boolean expression can consist of Boolean data such as the Boolean values yes or no and their synonyms or of true or false. So it could be yes or no, it could be on off, it could be true and false. So any kind of word will be used in it. Then we have the Boolean variables and formulas, functions that will give us the Boolean results and Boolean values calculated by comparison operators. So these are the things that will be considered in this Boolean expression. So Boolean function is it is described by an algebraic expression called Boolean expression. So any kind of expression that is described by the Boolean expression is called Boolean function. Basically, this function is a logic uh, behind the outputs that will be given by the Boolean expression. Now, this function consists of the binary variables, the constants 0 and 1, and the logic operation symbols. So consider the following example like f Boolean function equal to a, b, c, d. It first of all tells us how many variables should be used in it. Then expression, Boolean expression is like a or operation, then and operation b, c with negation plus a, d and c. This is the Boolean expression. Okay. Here the left side of the equation represents the output y. In this y, will get the results and the equation is like this. Mean to say this Boolean function will be considered as the Boolean expression. So truth table formation, it represents the table having all combinations of inputs and their corresponding results. So in the truth table, we have the expression and then results and see what type of results will be there. It is also possible to convert the switching equation into truth table. So this is the switching equation and we can convert it into the truth table. So like f a b c means three variables will be used and then the expression used in this function. So see, this is the truth table formation. The output will be high when A is high and or BC1 is high or both are 1. So like we have the equation here is A plus B C. Now this will tell us that whenever A is high, the equation is high. So first of all A is 0, BC is also 0. So result F is 0. Now here the AND operation is implemented. So A is 0 or B and C. Here AND operation is 0 and 1 is 0, 0, 0 is 0. Next is 0. Here OR operation is used, and in this AND operation is used. So 1 and 0 is 0 plus 0 is 0. Next is 0, 1 and 1. So here C, here BC is 1. The AND operation of both equations are B and C is 1. Here it is 0, but still we have, as per this equation, the output is high. And in all the other parts, when A is high, the result is high, even if B, the value of B and C is 0. Okay. So this is the truth table for this equation. So the number of rows in the truth table is 2 raised to power n, where n is the number of input variables. So we can figure out how many rows will be there in a table. It will always depend upon the number of variables used in it, and hence 2 raised to power 3 variables are used. So 3 equal to 8 possible input combinations are there. Clear? Okay, so the reduction of Boolean function method to reduce the Boolean function, that will be simply by using the Karnaugh map or K map. So the Boolean theorems and the De Morgan's theorems are useful in manipulating the logical expressions. So these and the De Morgan's theorem that we have discussed yesterday, as well as the Boolean theorems that will contain some Boolean function or Boolean expression, they are used to manipulate the logical expressions. So we are able to analyze that the logical expressions are created using the gates. So the number of logic gates required for the realization of a logical expression should be reduced to minimum possible values by K map. That means in this K map we have to work on the reduction of the logical gates that will be used in creating the circuit. Okay, so this method can be done in two different ways. They are SOP and POS, sum of products and product of sums. So sum of products is, it is in the form of sum of three terms AB, AC and BC, with each individual term is a product of two variables. So like A dot B and A dot C, etc. Therefore, such expressions are known as expression in sum of products. Basically, from the name suggests that we have some products like AB, AC, BC, and we are doing the sum of their products. Basically, sum of products is sum of their products. Okay, so here the product is being implemented. Here it is product, 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 and we are doing the addition of the products. So in fact, they are OR and functions. And in SOP, 0 represents a bar, whereas 1 represents an unbar. Like if A bar is there, we will represent it A0. And A1 means simply A. Clear? A bar is A0, whereas simple A is A1. The example of sum of product is like we have a equation A bar B bar plus A bar B plus AB. Okay. So by using this table, we use here AB, sorry, this is A bar B bar because these are different bar in it. This is A bar B and this is AB. Like 0, 1 and 3. 0, 1, 2 is not there. So answer is A bar B plus bar A bar B bar plus A bar B plus AB equal to A bar plus B. So see here we have reduced to the three AND gates and two logical gates to single OR gate. Clear?